Today we shall talk about how to check purity of milk by lactometer. Actually, lactometer is used for finding the purity of fresh milk supply from the dairy farm. It measures the relative density of milk with respect to the water. Milk is denser than water, so one can estimate that how much water has been added to the milk by using the lactometer. If more water would be present in the milk sample, then lactometer would sink deeper into that sample. Now, what is the working principle of the lactometer? Lactometer works on the Archimedes principle that a solid suspended in a fluid will be buoyed by a force equal to the weight of the fluid displaced. If the milk sample is pure, then the lactometer floats on it. And if it is mixed with water, then the lactometer sinks into that sample. Lactometer marking is in between 1 0.033 to 1.04. Pure milk is about 0.033 to 0.040 gram per ml is denser than the water. Now, we are taking the example of a lactometer here. This is a simple lactometer with the cylindrical tube which is graduated. This is the buoyancy bulb. This is the pitch. This is the mercury. So the air is filled into this tube so it can float into the water or into the milk sample. So you can see the marking here at the left side, 1, 1.01, 1.02, 1.03, and at the last we have the marking 1.04. On the right side, this is W, mean water, mean 100% water. There would be no milk in this water sample. And here, just opposite to 1.01, we have the mark 3 by 4. It's mean 75% water into the milk sample, which we are testing. If we are testing the milk sample and the lactometer is to be immersed into the milk sample and the surface of the milk is coincide with this mark that is 2.2 by 4 or 1.02, then it's mean this milk sample having 50% water. Similarly, we have 1 by 4. If this lactometer is immersed or sink up to this mark into the milk sample, then it's mean 25% water is present in this milk. And on the other hand, we can say 75% of the milk would be present in that sample. Here you can see from this mark to this mark, and from this mark, this where M is written. So we can say from this mark to this mark, the milk would be pure and no water would be added. So on the basis of the marking, W mean 100% water, M mean that is here 100% milk. So as we know, density of pure milk is in the range of 1.032 to 1.04 gram per ml. So in this range, milk would be considered without mixing of water in it. If any thickener would be added, then density would be above the M mark. This is the M mark. So in the presence of thickener, the lactometer would sink like here below M. And we can estimate about the thickener also with the help of the lactometer. This is the commercial lactometer. You can see the marking. This is the black mark. If it sinks up to this mark, then it's mean this is 100% water. If 3 by 4, it's mean 75% water. On the other hand, 25% milk. If it sinks up to 1 by 2, then 50% water, 50% milk. If this lactometer sink up to 1 by 4, then it's mean 25% water and 75% milk. Now this yellow mark you can see here, from here to here, if the sinking of the lactometer is here, or here, or here, or here, then we consider it the milk is 100% pure and there is no water in that milk sample. So black mark mean pure water, 3 by 4 mean milk is 25% with water, 1 by 2 mean milk is 50% with water, 1 by 4 mean milk is 75% with water. Yellow mark, milk is 100% without water. Here you can see how we can do or perform the practical. Take the milk into the glass jar or any glass and sink the lactometer into it. And there is a caution that this lactometer would not touch to the walls of the container. So it would be in the center. And for example, if this lactometer has been sucked on this mark, then we can read this mark. And from this mark, we can estimate the how much water has been added to that lactometer. So with the help of the lactometer, we can find out the percentage of water present in the milk sample.